Alright, in this video I'm going to go over converting motion graphs, specifically converting a position time graph to a velocity time graph. So just remember on all of these that the units on the time axis, all of these are going to represent 1 second, and everything on the position axis here is going to represent 1 meter, and everything on your velocity axis here is going to represent 1 meter per second. Just to make things easy, we'll keep all things in units of 1. So just a definition before we start. We're saying that velocity is going to equal the change in position over the change in time. Okay, remember when we did that in the lab from the graph? You would take a graph of position versus time, and it looked like that, and then you would find the slope for all these points, and the slope was equal to the velocity. So our equation for all of this is velocity is change in position over change in time. And we've already differentiated the difference between position and like displacement versus distance. So we're talking about vectors here. So if you go forwards, that's different than going backwards. Okay, so this is the equation we're using, which, you know, if you're talking about math, it's the same thing as your slope equation, which is delta y over delta x. All we're doing here is finding slopes. Okay? Okay, so let's start with an easy one. Let's do a graph that looks like this. Alright, so what I'm going to do is, let's say this is 1, 2, 3 seconds. So over here my velocity time graph is only going to go up to 3 seconds. So now I need to look at the slope of my position time graph. Slope is delta x over delta t. So for my first second, I'm going to break this down into 1 second intervals. For the first second, my rise is 2 meters. My run is 1 second. So my slope for that segment is 2 meters per second. It's meters per second because this is meters, this is seconds, and when I do rise over run, meters over seconds. That's how I get the units. For the second, hey, same thing. 2 meters, 1 second. 2 meters, 1 second. Right, so all I'm doing is finding the slope for each second. So over here, this is also a positive slope. It slopes up. That's positive. It doesn't slope down. So over here, this is my positive side. I'm going to go over to plus 2 as opposed to minus 2, which would be down here. And I'm going to plot my slope at each time period. So right here, it was 2 meters per second at 1 second. At 2 seconds, it was also 2 meters per second. At 3 seconds, it was also 2 meters per second. So my graph is going to look like that. Alright, so let's try one with a different slope. Let's say I'm going to start, I'm going to throw in this too. So here's, alright, so now let's try one with a different slope. And I'm going to throw something else in. Let's say here's 0 and here's 6. I'm going to start right here instead of starting at 0. And let's say I'm going to make my graph look like this. Alright, so now I'm not starting at 0 anymore. So remember, if I was drawing a motion map that looked like this, 1, 2, 3, 4, 5, I wouldn't start my dots over here. That would be wrong because I'm not at 0. I'd start it over here because I'm at 5. Right? That's 5 meters right here. And then I would be gradually working my way backwards. So again, let's analyze the slope of this. So for the first second, my rise is -1, right? I dropped down 1 meter. That's minus 1 meter. And my run was 1 second. So minus 1 meter over 1 second equals minus 1 meters per second. Same thing here. -1 meter, 1 second, minus 1 meter, 1 second, minus 1 meter, 1 second, minus 1 meter, 1 second. So the slope for all of these points is -1 meter per second. So remember, because we're talking about velocity, velocity is a vector. So the direction is mattering in this case. If we were just talking about speed, it would just be 1 meter per second because we don't care what direction we went. But because this is velocity, it matters that we're going this way on our motion map instead of going this way. This is the direction we're going, not that way. So the direction matters, and that negative sign matters. So if I come over here, again, I know that at every second on here, my slope is -1 meter per second. Here's 0 on my velocity time graph. Here's -1. So for every second, at 1 second, it's there. At 2 seconds, it's there. At 3 seconds, it's there. At 4 seconds, it's -1. At 5 seconds, it's -1. There's my velocity time graph. Alright, let's try another one of these, except this time I'm going to make it change speed. So I'll make it change at 3 seconds. So let's say for the first 3 seconds the graph looked like this, and then for the second 3 seconds it looked like this. Okay, so now I have two distinct segments. Before 3 seconds, everything over here, and after 3 seconds over here. I can see that because this slope got steeper for the second half, that it's sped up. So what I'm going to do, same thing, find the slope. So for here, your rise is 2 meters. The run is 3 seconds. So 2 meters over 3 seconds is 2/3 of a meter per second. And it's positive because it's going in the positive direction. So over here, that's +1 and +2. So 2/3 would be about here, somewhat. Right? And there's 3 seconds. So the first part of my graph would look kind of like that. The second part of my graph, same thing, let's just find the slope. So my rise is now 4 meters. My run is 3 seconds. So my slope is 4 meters over 3 seconds, which is 1 1/3 meter per second. So at 4 seconds it's 1 1/3, at 5 seconds it's 1 1/3, at 6 seconds it's 1 1/3. So 1 1/3 may be right there. Alright, so if you notice, at 3 seconds, that line changed instantaneously. So at 3 seconds, everything before 3 seconds was 2/3 of a meter per second. Everything after 3 seconds was 1 1/3. So that jump happened instantaneously. So my graph would look like that. 3 seconds was the changing point. So that's why at 3 seconds you see that little line jumping up right there. And that's my motion graph, my velocity time graph from that position graph. So you can look at it. This graph means that I started with a slower velocity down here, and I ended up with a faster velocity here, and it changed at 3 seconds. Alright, so I'm going to do one last one here, and this one I'm going to break up into 3 distinct parts. So my first part will look like this, and then I'll make the second 2 seconds look like that, and then I'll make the third 2 seconds look like that. Close enough. Alright, so for the first part, my rise is 4 meters, right? And my run is 2 seconds. So 4 meters over 2 seconds equals 2 meters per second. So over here, there's 1, there's 2, plus 2. This is positive, right? Because it's a positive slope. So my first 2 seconds will be 2 meters per second, like that. Notice that because the line starts at 0, it has the same velocity at 0 as it does everywhere. I'm starting over here from 0 seconds. So that velocity starting from 0 seconds is 2 meters per second. Okay, this middle section right here, this is easy because if you look at it, there's no rise right there. So if you want to be fancy about it and write out the equation, the rise is 0 meters, right, because it doesn't go up or down. The run is 2 seconds, so 0 divided by anything is 0. So it's 0 meters per second. So for this 2-second increment right here, the velocity is 0. So for seconds 3 and 4, it's 0. And again, because the change happened right here at 2 seconds, it happened instantaneously. So this line is going to jump straight down to 0 and become 0. Now the last part, same thing, rise, in this case, is -2, and the run is 2. So -2 meters over 2 seconds is -1 meter per second. So down here is -1. So it's going to look like that. And again, because that change happened instantaneously at 4 seconds, right, that's 4, it's going to jump straight down to -1. So that's what my graph would look like.